There you go.
Yeah. I got it good enough.
I'm smiling.
Hello everyone, my name is Sean Kelly. I'm with Active Grid Technology. First, I'd like to say Active Grid is honored that we were chosen to present at this symposium. Thank you for taking your time to listen to what we have to say, and we're going to try to excite this thing up a little bit. I will try.
He's very smart.
This product here, when I look at it, I see the future in energy storage. When you look at it, you probably think it looks like a box, something like this. And it is that box. But what this box is going to enable energy storage is going to be the future, and it's going to shift the paradigm of the way we currently use it. We have basically one patent that's been in the works since 2003, priority date, and we have another patent pending. The first one is the base patent, and that's what this base electronics based off of, and it's basically our first marketing aspect as well. The second patent pending is the next level of this technology, which is going to be utilizing the same mechanical energy excitation in the battery to basically solicit better state of health information from the battery. When you combine the two effects, the base patent and the monitoring effect, you have an extremely novel and innovative battery management system. The main lines of operation that we're doing right now is prototype and product development, developing strategic IP portfolio, pursuing real value added license opportunities, which I'll talk to you about a little later, field testing and demonstrations across many chemistries and applications, basically low rate level production, and also hardware and software development focused on full rate production readiness. Active Grid Technology is a Massachusetts S Corp, veteran owned. I am a veteran. I also have 21 years submarine nuclear service and commercial nuclear power for the last 8 or so years, delivering instrumentation and control systems. My director of operations is Mike Galgana. Ruud Swans is business development. James Metz is an advisor, and so is Dave Olivier with those companies. My executive assistants, the beautiful woman over there, she's here with me, and she's my wife as well. Prior investments in the company, about $250,000, and we've done a few things, several things with that. It enabled us to come up with a base product. We went through 3 major testing evolutions with major companies. We developed many different conceptual battery management systems designs, several white papers integrating this base nugget into their designs. And we've done a lot of market research, conferences, events, been in several newspaper articles, magazine articles. So we've been getting around. We purposely move things inside your battery, and where we're different is we don't move your battery. In the past, 30, 40 years ago, they tried this. They tried to put ultrasonic energy onto a battery to make it perform better, get rid of that nasty deposit for lead acid and sulfation. They didn't do it right because they went at very low frequencies in the kilohertz region, 40, 50 to 100 kilohertz. Well, it just so happened some of the batteries that they were shaking, they were getting short-term great effects, and then a little while later they noticed the lead plate started falling and crumbling apart. Well, we teach away from that in Active Grid Technology. We use very high frequencies. Our waveforms are very, very small, and it interacts with the reaction products in the battery during both discharge and charge. What happens when we interact with these electrochemical reaction process? We get improved energy efficiencies, conversion efficiencies, enhanced capacity, and extended life. We're basically minimizing the inherent ionic kinetic inefficiencies in a battery.
Oh, Jesus, I keep
There's a
losing.
big difference between a battery and a capacitor. The capacitor has no ions. The battery does. But we're speeding those ions up. So batteries with active grid technology applied are going to behave more like a capacitor with the energy storage of a battery. It's adaptable to any battery, cell, structure, size, or shape, and it's adaptable. The patent is broad enough, it covers all battery chemistries. Some of the enhancements we have seen through testing is energy efficiency increases, storage capacity increase, discharge rate increase, cycle life, charge acceptance, state of health and state of charge measurement accuracy, and control and energy management type options. The one thing that I want to be clear here, the testing, we didn't test the state of health and state of charge accuracy measures at this point. This is theoretical based on our original testing. The actuators we use are PZT. PZT, lead circuit tightened, is a known piezoelectric material. I believe as Energy came up and he was talking about ceramics. I would like to talk to that company to see if I can make your ceramic sheet and give it the piezoelectric property that I need to make my batteries better. That would be great. If you don't know what PZT is, if you squeeze it, it creates a voltage. If you put a voltage on it, it deforms. And what we're doing in a battery is we're deforming it very fast. Expansion and contraction in the megahertz region. Very fast. So there's several different ways to go at this. I can get the ultrasonic energy into the battery from the outside, of which I have a device right here. You're welcome to, we basically cut the terminals off and we insert our actuation device right into the pre-existing battery. What does that do? Well, it obviates the need to replace a battery pack at a central office that could cost anywhere from $150,000 to $275,000, and we can incorporate our system for $35,000. And we could probably extend the battery pack's life until the director of engineering retires. All right, that'll be our goal. If we put it inside the battery, we're going to be using materials like electroactive polymers. You might have heard recently in the science area. Nanocarbon tools. Nanocarbon. That reminds me of Thermoquar, the guy that was just up here a little while ago, talking about nano. Well, I'd love to talk to him about how I'm going to dope my plates inside my batteries or someone else's batteries and make them work better. Etched silicon. Did you know that you can turn silicon into a piezoelectric material just by correctly etching it? And some other things too there. PVDF, copolymers, PMN, which is a special favorite of mine. That's, I don't know what it stands for, but anyway, it causes the electrostriction effect. And when I went to school, I did a 2-year nonlinear model on that, those things stacked one on top of another. Activated carbon. Activated carbon actually grows PZT inside. You can do it. And you get these little PZT fibers that could be vibrated at the frequency, which makes everything work good in the battery. Graphene, Nobel Prize in 2010. It's just discovered at Stanford by a couple students. You add one atom to it, and all of a sudden it's the best piezoelectric property material ever. And relatively low cost, we can add it to your battery pack and your strings. And how do we do it? The effects of the ultrasonic energy is we increase the utilization of the active material in the battery. So given that, and we had our systems, if you look over to the pointer, how do you go backwards? You shouldn't be back 2 slides? No, go forward. Go. Right here. Go back. Thanks. Okay. So the net base on the top left side, that's $1,200 right now, today. Go out and buy a battery pack with active grid technology. These are 3 configurations we can save money. 3 battery string, we can say, go buy cheaper batteries, put our device on, it will operate better than you ever had before. We can say, go buy smaller and cheaper batteries. If you have some kind of area constraint, they'll operate better, and you're going to save on the order of $480 on that savings. And if you just go to 2 strings, because with active grid technology, you don't need 3 strings. Okay. Right here, if you look at a typical battery that's 3-year life, if we increase the performance, which we did in testing, by 75% and extend the life by 2 years, we're in the green, and that's a good thing. We're a 2-tiered approach. Right now, this is Gen 1 product. We're going to sell these. We're going to sell them to battery integrators, battery end users. We're going to put them on there. In our second, later approach, we're going to license little nuggets. Can I go? Am I on time? Okay. I just wanted to show the video.
Let me see.
No video.
Video was good.
Can't hear you.
Sorry. You've got some energy you're putting in to make this effect happen. Can you quantify what that is and what the output effect is?
Right, so we have energy coming in from the DC power supports the battery. This little device here is very efficient. This particular one runs off 12 volts DC, so we have applied to car batteries. And the efficiency of the circuitry in here is on the order of 90 to 95% efficient. Right now, it's getting better. And this device efficiency right here, the PZT elements right here, is probably the most inefficient method. But as far as quantifying energy, we're at a fraction of what the battery's putting out. We use it, so we basically take the mechanical energy and assist the electrical charge and discharge of the mechanical. Any others?
What's the fraction?
Say it again?
Well,
Oh,